Hi parents, welcome to Unity Connects. Today we'll be sharing on how model drawings could help our lower primary students in solving word problems. We will be introducing the two types of model drawing. One is the part whole model and the other one will be the comparison model.
At the end of this session, parents will be able to understand what model drawing is, make use of model drawing to solve word problems, support their child in using model drawing to solve word problems. Let's look at the content of today's session. This presentation includes Introduction to Model Drawing. What is model drawing? Why use model drawing? How does model drawing help? Introduction to part whole model. Introduction to comparison model. At the end of the presentation, there will also be a simple quiz for parents. So, what is model drawing? Model drawing is a strategy that provides a concrete, visual representation to help students better understand word problem. Model drawing can be used at any level from kindergarten to high school. For the elementary and middle school students, two common models can be used to solve most word problems. Next, let's learn what is model drawing in Singapore. Basically, drawing models require you to draw boxes or rectangles to represent numbers. Drawing models enable us to compare numbers, fractions, ratio, and percentages easily. After learning what model drawing is, let us understand the different types of bar models. There are two common types of bar models used by the lower primary. Part whole model. We use part whole model to find the total given the two parts, to find the part given the total. Comparison model. We use comparison model to find the difference. My colleagues will elaborate more on the types of bar models in the next segment. How does model drawing help? By drawing a pictorial model of a word problem, students are able to visualize, represent, and relate the known and unknown quantities in the word problem. Bar models also help students develop their mathematical thinking, communication, reasoning, and problem-solving skills. Why use model drawing? So let me give you the reasons why we use model drawing. It's easy to use. It helps students visualize situations. It creates concrete pictures from abstract situations, and it do away with complex algebra. Next, my colleagues will give you an introduction to the two types of model drawing.
Let's move on to the next segment of our presentation, which is an introduction to part whole model. What is a part whole model? It is a pictorial representation that shows the relationship between a whole and its parts. How do we introduce part whole model to the students? First, we will use concrete objects to illustrate the problem. Next, we will introduce the pictures that represent the objects. After that, we will draw boxes around the pictures before they are being removed. Then, the individual boxes will be replaced by rectangles. Lastly, we will label the model by inserting the key information from the word problem. Next, let's go through an example to illustrate the steps to teach part-whole model. There are 5 green apples and 3 red apples. How many apples are there altogether? First, we will use real apples to illustrate the problem. Next, we will replace the concrete objects with pictures of apples. Then, boxes will be drawn around the pictures of apples. After that, the pictures of apples will be removed. The individual boxes will be replaced by the rectangles. Key information from the question will be inserted into the model. We are using the CPA approach, which is the concrete, pictorial, abstract approach to teach problem solving to our students. Let's take a look at the steps to solve a word problem. We have to read the word problem. Reading once may not be sufficient. It is better to read at least 2 to 3 times to have a better understanding of the word problem. While we read, we have to look for key information and underline or highlight them. This is to ensure that we do not miss out any important information. After that, we will construct the model based on the information given. Analyze and decide on which operation to use. That is, add, subtract, multiply, or divide. How do we analyze a part-whole model to solve the word problem? If the values of parts A and B are given, and we have to find the value of the whole, we have to add the numbers for parts A and B. From the part-whole model, if the values of the whole and the part are given, we have to subtract the numbers, which is A minus B, to find the missing part. Today, we will be sharing with you some word problems which we can use part-whole model to help us to solve. Basically, the word problems will be classified into 2 parts. The first part will be some typical word problems which involve the putting together and set and subsets concepts. Next, we will introduce the other types of word problems which involve some movements like giving away or receiving. Let's take a look at a typical word problem which involves the putting together concept. Before we move on, do you still remember the steps to solve a word problem? We have to read the word problem, look for key information, and then construct the model. Jane baked 5 chocolate and 7 vanilla muffins. How many muffins did she bake altogether? Let's identify the key information and construct the model. Jane baked 5 chocolate muffins, 7 vanilla muffins. We have to find the number of muffins she baked altogether. Next, we have to analyze the model and decide on whether to add or subtract the given numbers to find the answer. From the part-whole model, we can see that the value of the whole is missing. So we have to add the parts to find the total number of muffins Jane baked. 5 plus 7 equals 12. She baked 12 muffins altogether. Let's move on to another typical example of word problem which illustrates the set and subsets concept. Jane baked 12 muffins. 5 were chocolate muffins and the rest were vanilla muffins. How many vanilla muffins did she bake? Let's identify the key information and construct the model. Jane baked 12 muffins. 5 were chocolate muffins. The rest were vanilla muffins. We need to find out the number of vanilla muffins Jane baked. Let's analyze the model. The unknown is the pink part. So we have to take the whole 12 to subtract the blue part 5 to find the number of vanilla muffins Jane baked. 12 minus 5 equals 7. She baked 7 vanilla muffins. Now, we will move on to the other types of word problems involving part-whole model. Let's take a look at these 4 word problems. Word problem 1. Jane had some muffins. She gave 3 muffins to Alice and had 9 muffins left. How many muffins did Jane have at first? Word problem 2. Jane had 12 muffins. She gave some muffins to Alice and had 4 left. How many muffins did Jane give Alice? Word problem 3. Jane has 12 muffins. She gives 2 muffins to Alice. How many muffins does Jane have now? Word problem 4. Jane has 12 muffins. Alice gives her another 5 muffins. How many muffins does Jane have now? These 4 word problems look similar. All of them involve 2 ladies, some muffins, and also movement of the muffins. However, there are differences between them, as what we want to find in these word problems are different. For word problem 1, we are finding the start, the number of muffins Jane had at first. For word problem 2, we are finding the number of muffins Jane gave Alice, which is the change. For word problem 3 and 4, we are finding the end result, which is the number of muffins Jane has now. However, there is a difference between word problem 3 and 4. We will explain further in the following slides. Let's take a look at this example of finding start. Jane had some muffins. She gave 3 muffins to Alice and had 9 muffins left. How many muffins did Jane have at first? In this question, the phrase at first at the last sentence tells us that we have to find the number of muffins that Jane had from the start. Let's construct the model based on the key information we identify from the question. Jane had some muffins. She gave 3 muffins to Alice, had 9 muffins left. We have to find the number of muffins Jane had at first. From the model, we can see that the parts are given and the whole is unknown. In this case, we have to add the parts together to find the whole. So, 9 plus 3 is equal to 12. Jane had 12 muffins at first. Let's take a look at the second type of word problems which involve movement. Jane had 12 muffins. She gave some muffins to Alice and had 4 left. How many muffins did Jane give Alice? What is the difference between this question and the previous question? In this word problem, the number of muffins that Jane had at the start was given. Then later, there was a change in the number as Jane gave some muffins to her friend Alice. In the end, she had 4 left. In this question, we have to find the amount of change, which is the number of muffins Jane gave Alice. For the previous question, we have to find the number of muffins Jane had at first, which is the start. Let's construct a model. Jane had 12 muffins. She gave some muffins to Alice and had 4 left. How many muffins Jane gave Alice is the unknown. From the diagram, we can see that the whole is given and the part is unknown. So, to find the answer, we have to subtract 4 from 12. The answer is 8. Jane gave 8 muffins to Alice. Let's move on to another type of word problem which requires us to find the end. Jane has 12 muffins. She gives 2 muffins to Alice. How many muffins does Jane have now? In this word problem, we know the number of muffins Jane has at the start, which is 12. We want to find the number of muffins she has after giving 2 muffins to Alice, which in this case is finding the end result. Let's construct the model. Jane has 12 muffins. She gives 2 muffins to Alice. How many muffins Jane have now? From the model, we will know what operation to use. A part is missing, so to find its value, we subtract the other part from the whole. 12 minus 2 equals 10. Jane has 10 muffins now, after giving 2 muffins to Alice. This word problem also requires us to find the end result. Jane has 12 muffins. Alice gives her another 5 muffins. How many muffins does Jane have now? This question may look similar to the example before, as both require us to find the number of muffins Jane has now. However, there's a difference. What do you think is the difference? In the previous example, the movement involves Jane giving away her muffins. In this example, the movement is the opposite. Jane receives muffins from her friend Alice. Although in these two questions, the last sentences are exactly the same, the models are different and the operations that we use to solve the two problems will be different too. Jane has 12 muffins. Alice gives her another 5 muffins. How many muffins does Jane have now? From the model, we can see that the whole is unknown, so we have to add the parts. 12 plus 5 equals 17. Jane has 17 muffins now. Now, we will have a hands-on session where you can try drawing part-whole model to solve the word problems. Parents, please pause the video while you attempt the question. Press resume whenever you are ready to check the answer. Question 1. Ben went to a fruit store. He bought 16 oranges and 9 pears. How many oranges and pears did Ben buy altogether? Please pause the video while you attempt the question. In this question, Ben bought 2 different types of fruits, and we have to find the total number of fruits he bought. From the model, the whole is unknown, so we have to add the parts to find the whole. 9 plus 16 equals 25. He bought 25 oranges and pears altogether. Let's try another question. Joy has 63 stickers. She gives 28 stickers to Rachel. How many stickers does Joy have left? Please pause the video while you attempt the question. In this question, we have to find the end, which is the number of stickers Joy has left after giving some to Rachel. From the model, the part is unknown, so we have to subtract 28 from the whole 63. And the answer is 35. Joy has 35 stickers left.
Next, we will move on to part 2 of our model drawing sharing, which is the comparison model, another type of model the students commonly use to solve word problems. Comparison word problems involve comparing the quantity of 2 or more items. There are mainly 2 types of comparison word problems: finding difference as well as more than or fewer than. Let us look at a question which requires us to find the difference. Ayin has 6 dolls. Jane has 11 dolls. How many more dolls does Jane have than Ayin? Upon seeing this problem, some of the pupils will tell you the answer is 17. They get 17 by adding the two numbers 6 and 11, which is in the question. This is because they see the word more. They think that they have to add when there is a word more in the question. So, it is important to comprehend the whole question instead of just solving the problem sum by identifying key word. For a start, we can start visualizing and comparing who has more dolls. Ayin has 6 dolls and Jane has 11 dolls. Jane has more dolls than Ayin, so Jane's model bar will be longer than Ayin's. The part that represents the more will be the extra part behind Jane after comparing with Ayin. We take what Jane has and subtract what Ayin has to find the extra part, which represents the number of dolls Jane has more than Ayin. Let us look at another question which requires us to find the difference. Ayin has 6 dolls. Jane has 11 dolls. How many fewer dolls does Ayin have than Jane? Again, for a start, we can start visualizing and comparing who has fewer dolls. Ayin has 6 dolls and Jane has 11 dolls. Ayin has fewer dolls than Jane, so her model bar will be shorter than Jane. The part that represents the fewer will be the part that she needs to add on to be the same as Jane. It is also the extra part behind Jane after comparing with Ayin. We take what Jane has and subtract what Ayin has to find that extra part Ayin needs to have to be the same as Jane, which represents the number of dolls Ayin has fewer than Jane. If you look back at the two problems discussed earlier, you will notice that they have the same solution, but the questions are phrased differently. It is important for students to read and understand the question. Drawing a model will help them visualize the problem and identify the correct operation to solve the problem. It is important to emphasize to students that more than does not simply mean add, and fewer than does not simply mean subtract. We will go on to another type of comparison word problem. There are 8 butter cookies. There are 7 more chocolate cookies than butter cookies. How many chocolate cookies are there? While constructing the model, it is important for us to think of a few questions. Firstly, which cookie will have a shorter model bar? Which cookie will have a longer bar? In this question, since there are more chocolate cookies than butter cookies, the bar representing chocolate cookies will be longer than the bar representing butter cookies. The chocolate cookies model bar is actually made up of the butter cookies bar and 7 more cookies. Therefore, to find the chocolate cookies, we add 8 and 7 to get 15. Let us take a look at another word problem. There are 20 butter cookies. There are 7 more butter cookies than chocolate cookies. How many chocolate cookies are there? Since there are more butter cookies than chocolate cookies, the bar representing the number of butter cookies is longer than the bar representing the chocolate cookies. The part representing 7 is the extra part from the butter cookies after comparing both cookies. To find the number of chocolate cookies, we subtract 7 from 20, and therefore there are 13 chocolate cookies. While both word problems discussed earlier require us to find the number of chocolate cookies, In both questions, we are comparing them differently. The model bar representing the chocolate cookies will be longer than the butter cookies in question 1. The model bar representing the butter cookies will be longer than the chocolate cookies in question 2. As such, different operation is required to solve the two word problems, which looks rather similar. Having the word more than in both questions does not simply mean we add to get the answer. The examples above shows us more than may not simply mean add, fewer than may not simply mean subtract. Simply looking out for words such as more than and less than and deciding on the operation to solve the word problem based on that may not lead us to the correct solution. It is important for us to understand the given quantities in the question, visualize and construct a model, analyze the model to solve the word problem. Now, we will have a hands-on session where you can try drawing comparison model to solve the word problem. Parents, please pause the video while you attempt the question. Press resume whenever you are ready to check the answer. There are 15 cups of blueberry ice cream. There are 6 fewer cups of blueberry ice cream than chocolate ice cream. How many cups of chocolate ice cream are there? Please pause the video while you attempt the question. Key questions to take note of are: which ice cream has a longer bar? Which ice cream has a shorter bar? And what do we need to find? Since there are fewer cups of blueberry ice cream than chocolate ice cream, we know that the bar representing chocolate ice cream will be longer than the bar representing blueberry ice cream. As seen from the model, the bar representing the chocolate ice cream is made up of two parts, the part representing 15 and 6. Therefore, to find the number of chocolate ice cream, we add 15 and 6. There are 21 cups of chocolate ice cream. Ali has 11 pencils. Lily has 18 pencils. How many more pencils does Lily have than Ali? Please pause the video while you attempt the question. Key questions to take note of are: who has a longer bar? Who has a shorter bar? And what do we need to find? Since Ali has 11 pencils and Lily has 18 pencils, Lily has more pencils than Ali, so the bar representing Lily's pencils will be longer than Ali's pencils. To find how many more pencils Lily has than Ali, we need to find the extra part that Lily has compared to Ali. That extra part can be found by subtracting what Ali has from what Lily has. Therefore, we subtract 11 from 18 to find how many more pencils Lily has than Ali. Lily has 7 more pencils than Ali. To summarize what we have learned, now it is quiz time. For each word problem, the question and solution will be provided. You have to identify the question type. For example, whether the word problem is a typical part-whole word problem, which involves the set and subset concept, or whether it is a finding start part-whole word problem, or it is a finding difference comparison word problem. Are you ready? What is the question type of this word problem? Parents, please pause the video while you attempt the question. Press resume whenever you are ready to check the answer. In this question, the clown has two types of balloons, green and pink balloons. He has a total of 18 balloons. 4 of them are green and the number of pink balloons is unknown. This word problem is a typical type 2 part-whole word problem which involves the set and subsets concept. What is the question type of this word problem? Please pause the video while you attempt the question. In this question, Tom has 45 blue pens and 30 red pens. We are comparing the number of blue and red pens that Tom has, and therefore, this is a finding difference comparison word problem. What is the question type of this word problem? Please pause the video while you attempt the question. This question requires us to find the number of egg tarts Mrs. Lim baked at first. It is a finding start word problem which we can use the part-whole model to help us solve it. What is the question type of this word problem? Please pause the video while you attempt the question. In this question, we have to find the number of blue marbles. We know that there are 21 fewer red marbles than blue marbles. We can use the comparison model to solve this word problem. This is a more than or fewer than comparison word problem. We have come to the end of the mathematics sharing for lower primary in this month's Unity Connects 2022. Please scan the QR code and give your feedback for this sharing. Thank you.